Hello everyone, this is Bhavesh Kriplani and welcome back to this wonderful series where we discuss some unique and fantastic concepts and we learn where to use them. So in today's video, we'll be doing a small experiment. Okay, this experiment is based on instantaneous axis of rotation. So let's look at that first.
We have got two pens over here, blue one and red one. Now we'll do a simple experiment where I will hit the blue pen and we'll see whether the blue pen is coming into contact with the red one. So first I'll hit the blue pen at this point and we see that it did not come in contact with the red one. Now let's try again, but this time we'll hit the blue pen at this point and let's see what happens again. And we observe that the blue pen hit the red pen. Now you have to tell me why did this happen.
So this experiment is very simple. It is based on instantaneous axis of rotation and sweet spot. I have discussed sweet spot, instantaneous axis of rotation and a very elegant formula in this previous video. The link is available over here. If you haven't seen this video, so watch it now and then come back over here. Okay, let's continue. So first of all, the question is, why do we need axis of rotation in this case? Because when you are hitting the pen will follow a combined rotation plus translational motion. Okay, and in that case, right after we hit the pen will appear to rotate about a particular axis somewhere along this line. Okay, that axis may be on the pen or outside the pen. Alright, and based on the position of the axis of rotation, the two pen may or may not come in contact. So let's look at the various possible cases. So let's take the first case where the axis of rotation is at the center of this pen. So in that case, the pen will rotate like this, okay, and obviously it is hitting the lower pen over here, right? Let's try one more position. So in this case, the axis of rotation is slightly shifted. What will happen? When the pen rotates, again both of them are going to come in contact. Okay, let's try one more situation. So now the axis of rotation is at the edge or the end of the pen. So in this case, the two pen will not come in contact. Okay, now what if the axis of rotation is outside the pen? In that case also they will not come in contact. Okay, now we can understand the situation using the formula that we discussed in the previous video. Okay, so let's take the situation where we don't want the contact between the two pen. So in that case, what are the axes of rotation required? Either the axis should be at the end of the pen or it should be outside the pen, correct? So in that case, the distance of the axis of rotation from the center, that is x1, will be L by 2 or more than L by 2. Alright, now let's come back to this formula. Okay, so first of all, let's assume that the pen is a simple uniform rod. So in that case, the radius of gyration about the center of mass, Kc, will be L by root 12. Right? In that case, we can use this formula x1 x2 equal to kc square or x1 x2 equal to L square by 12, where x1 is the distance of axis of rotation from the center and x2 is the distance of the point where you will be hitting the rod, okay, from the center, right? So x1 will give me axis of rotation and x2 will be the sweet spot. So for the situation of no contact, the axis of rotation should be either at the end of the pen or it should be outside the pen. Then x1 should be either equal to L by 2 or more than L by 2. Right? Then the point where you apply the impulse, its distance from the center, okay, should be either equal to L by 6 or it should be less than L by 6. In that case, in this small distance, if you hit on the pen, the two pen will not come in contact. But if you go beyond L by 6, in this region, wherever you hit the pen, the two pen will definitely come in contact. So like I told you in the last video that x1 x2 equal to kc square, the formula for sweet spot, is really wonderful because it helps you solve several types of problems within minutes. Here also we have used that formula in a real life situation and we could solve this problem without too much of calculations involved. Now I have got a simple question for you. Okay, again we got the two pen over here kept near each other and I am flicking or I am applying an impulse J at this end of the pen, what do you think will happen? Obviously, the distance of impulse is more than L by 6 from the center. So the two pen will definitely come in contact. So now here's my question. Assume that the pen has mass m, okay, and you are applying an impulse J. So what will be the velocity of the center of mass of the pen? Will it be equal to J by m, less than J by m, more than J by m, or the data given is insufficient? Don't forget to like this video, subscribe to the channel, click on the bell icon and share this video with everyone.